Today we will discuss about synchronous generator or its alternate name is alternator, and first of all we have to see its operation. So an alternator operation is based on Faraday's law of electromagnetic induction. So here when the magnetic field changes, an EMF is induced in the nearby conductor. So if we talk as alternator is used in many of the industries just like gas, hydro power plant, wave steel power plant, nuclear power plant. So there are so many uses of an alternator. So we will go to the next slide. So this is the internal structure of the alternator. These are the armature conductors, and this is the slip rings present in the shaft. Okay, and the center part is the rotor. The center part is the rotor, and these are the poles, the field poles. Okay, so we will go to the next slide. So here we can see that there are normally two types of alternator. One is cylindrical rotor alternator, another is salient pole alternator. So this is a cylindrical rotor alternator. In a cylindrical rotor alternator, the rotor consists of conductors. Rotor consists of conductors, field conductors, and the starter consists of starter conductors. Here, due to the change in magnetic field in the rotor, a flux is circulating in the machine, and so an EMF is induced in these conductors. Okay. So these lines are the magnetic flux lines that is inside, that is around the conductors. And in the next slide, this is another type of alternator which is called salient pole type alternator. In salient pole type alternator, the center of the rotor is consist of field poles, and the starter consists of conductors, armature conductors. So from this diagram we can see that this is a 4-pole salient rotor. Okay, and in salient pole machine, the field winding is wound over the poles, and the armature winding is wound over the armature conductors. So we will go to the next slide. Okay, this is the principle of operation of an alternator. Here, due to the rotation of the rotor, which is placed in the between the magnetic poles, there is an EMF which is induced in the armature conductors. Okay, and that EMF is brought to the load by the slip rings. Okay, this is the basic difference between a AC machine and a DC machine. In a DC machine, instead of slip ring, there is a commutator, but in AC machine, commutator is not there. So slip ring helps those EMF to come to the output. So this is the principle of operation where due to the field excitation, EMF is induced in the rotor or in the armature conductors. Next, here also we can see that the slip ring is connected to the field excitation, and the armature conductors are poles. The armature conductors are inside the poles. So this is the diagram of a single phase alternator. Here a 2-pole, that is north and south, a 2-pole field winding is placed between the alternator, and here the starter is 2-pole and the winding pulled over the distinct distance between the 2 poles. Next, so a single phase alternator is totally different from 3-phase alternator, because in a 3-phase alternator there are 3 phases R, Y, B, but in a single phase alternator there is only one phase, that is positive, negative, and the output is different from the 3-phase alternator. In a single phase alternator the output is totally different. Here we can see that the rotor consists of field winding and the starter consists of the armature winding, which can be seen from the diagram. So if we again discuss about three-phase alternator, this is the waveform of the three-phase alternator. ABC stands for the three phases, RYB. ABC stands for the three phases, and all the three phases are 120 degree apart from each other. So this is phase A voltage, this is phase B voltage, and this is phase C voltage. All the voltages are apart 120 degree from each other. Next slide. So three-phase alternator is most probably there are two types of voltage. One is phase voltage, another is line voltage. And a three-phase connection is of two types: star connection and delta connection. So in both the connection, the line and phase quantities are different. In star connection, the line voltage is equal to √3 of phase voltage, and the line current is equal to the phase current. But in delta connection, it is opposite. In delta connection, the line voltage is equal to the phase voltage, and the line current is equal to √3 of the phase current. Okay, so what we can see here, star and delta connection. Yes, this is the diagram of star connection, the three phase ABC, and this is the diagram of the delta connection, the three phase ABC. Okay, for simplicity we are taking as ABC, but actually it was RYB, but for the simplicity we are taking as ABC. So this is the basic about a three phase alternator. And further, if we want to find any of the value of a three phase alternator, we are using this formula for finding the frequency. F equal to N means speed of the rotor, into P by 2. P stands for the number of poles divided by 60, or simply we can write NP divided by 120. So find the frequency of a three phase alternator. Of a three phase alternator, we are using this formula, F equal to NP by 120. So again we are comparing both three phase and a single phase alternator. This is the waveform of three phase alternator. This is the waveform of single phase alternator. But both alternator have the same formula of frequency, that is F equal to NP by 120 degree. Here this machine contain 8 pole and this machine contain only 2 pole. So this is all about your three phase. Now we will go into the variation of voltage according to the load. If the load is resistive or the load is inductive, then how the voltage will vary. So I think everyone understood what is the three phase alternator is about. Okay, so thank you.